we're going to use the run as command. We're going to do run-as and then provide it with the name of the package. And grand finale, ladies and gentlemen, we now have access to the private data directory of this Android application. Every Android app runs inside of a sandbox. And under normal conditions, you can't just step inside it. But there's one flag that, if added to the Android manifest file, changes everything. Android debuggable equals true. In this video, I'm going to walk you through a hands-on demonstration using an app that I created that I have permission to modify. We'll extract the APK from the phone. We'll decompile it using APKTool, examine the manifest, modify the app, realign it, re-sign it, rebuild it, reinstall it back onto the phone. The goal is to understand how the Android sandbox model works. So let's step inside this APK. Everything that we are about to do in this video is for educational reasons only. Do not do this on apps in the Play Store or apps you do not have permission or authorization to test or modify. This app is available on my GitHub repository. I wrote it. It is a very crappy app. Its sole purpose is really just for this demo and other demos similar to this one right here. It's not meant to be a real note-taking app, but it allows us to do these things in a legal and ethical way without crossing any boundaries. Feel free to get the app and follow along with what I am about to show you. Over on the right hand side, I'm mirroring the screen of my phone. I have the app already installed on my Google Pixel. You can see it is green right here. It's called Fresh Forensics Vault. It is a very secure note-taking app, somewhere where you should store all your passwords and email addresses. My phone is connected. I can verify that I have a connection and that USB debugging is properly authorized. You see the device is listed as attached. I have authorization. I can shell into the device by running adb shell. So this is apktool.org. APKTool is a tool for reverse engineering Android APK files. You can use this to disassemble the resources to nearly original form. You can use it to assemble. You can use it to analyze. You can modify apps that you own. There's so much that you can do with this tool. It's the starting point. It's incredible. So I'm going to come up here to the upper left. I'm going to click on the install link. That takes us to the install guide. Obviously, we are using Linux. So you first need to download the Linux wrapper script. This is very important. So you're going to click on this. You're going to right click on this, and you're going to click Save Link As. This is going to save this file in your downloads directory. It's going to save it as APKTool. Next, you need to download the latest version of APKTool. You can follow this link, which will take you to bitbucket.org, or you can just head over to their GitHub page. Link will be in the description. This is their GitHub page. And you can come over here to releases and click on latest. The latest release as of this video is version 3.0.1. Come down here to the assets. You're looking for this file right here, apktool.jar. Whatever the version is, you'll see the version in between. This is version 3.0.1. So you're also going to download this file. I've already downloaded both of these files. I'm going to bring them over to my current directory. So here's the wrapper script, APKTool. Here is the .jar. We're going to rename APKTool 3.0.1.jar to APKTool.jar. So I'm going to run chmod +x on APKTool as well as APKTool.jar. And finally, we're going to move both of these files at once. You need sudo privileges. We're going to run sudo move APKTool. I'm going to use an asterisk so it moves both of them at once. We're moving them over to /user/local/bin. I can verify that by running ls on that path. and they both are where they need to be. So now if we run APKTool -- version, you see that we now are using the latest version of APKTool. And if I run which on APKTool, you see it has already identified that path. Technically, we still have the other version installed, and you could just remove that. Probably be the best thing to do to just remove that so there's no confusion, but the system is already recognizing this new path, so I am just going to use it. We are going to get the name of the package that is installed on this phone by running adb shell pm list packages. I'm going to pipe it into grep. I'm grepping for something with fresh, or I'll grep for something with vault. I know that those are in the name. Here's the name of the package. Next, we're going to get the path. We need the path to where it's stored on the phone in order to be able to pull it from the phone. I'll do that by running adb shell pm list packages with a -f. It'll provide me with the path. I'm going to pipe that into grep, providing the actual name of that package, and now we have the path. We're going to copy that path starting with /data all the way over to base.apk, and we're going to run adb pull, paste in that path, hit enter, and now it just pulled that application from the phone, and it's in this directory. It's called base APK. Also, since we are actually going to modify the app now, this would be a good time to just uninstall the app, because we'll have issues if we try to reinstall that new modified app back onto this phone. There will be a conflict with the names. So we're going to actually uninstall the app now. We're going to run adb uninstall -- user followed by 0. That's the default user of the phone, followed by the name of the app. We're going to go ahead and remove that, uninstall it. Next, we're going to use APKTool. We're going to decode or decompile the app with D-O is the directory everything is going to be sent to. This is a newly created directory. We're going to call that directory extracted. And finally specify the app you're running this on, which is base.apk. APKTool has completed. Now we have this newly created directory called extracted. I'm going to cd inside of that directory. This is what it looks like. We're going to open up the Android manifest.xml file. Right up here near the top, you have permission, uses permission, you have application. We're going to come right down to that line that starts with application, and we're going to come right over here after allow backup equals false, and we're going to add a new line. We're going to add Android : debuggable equals true. True is inside of double quotation marks. So this is the line that we're adding. Android : debuggable equals true. This is essentially making this app debuggable now. You typically would not find this on a production build. On a release build, you should not find that it's debuggable, though I'm sure it does happen. We're going to do a Control-X and a Y, enter to save. So we just modified this app. We modified one small line in this app, but nonetheless, we just modified it. I'm going to cd back outside of this directory, clear the screen, do an ls. Now we're going to use APKTool, and we are going to rebuild this application. We're going to run APKTool with a B for build. We're going to specify that directory that contains all the extracted files that we just modified a file inside of. It's called extracted. Next, I'm going to do a -O, and this is going to be where the new application is sent to, where this -O is where you specify the name of the new application. This is different than the original one, so you just want to name it something that lets you know, hey, this is the thing I just did. So I'm going to call it modified.apk, letting me know this is when I modified it. Hit completed. If I do an ls, there we go. So we can actually run ls-l on base APK. We'll rerun that on modified APK. And you can actually see that there is a difference in the size now. So undoubtedly this has been changed. So if there was a hash, hashes are no longer going to match, none of that. Okay, so now what happens if we attempt to install this on the phone? We uninstalled the previous version. Let's see what happens if we attempt to install it. I'm going to run adb install, and we're going to install the modified APK. So we get a failed message. It failed to install the APK. It wasn't able to parse the certificates. The reason why you're seeing this is because we have not signed it. We need to sign this. The original app was signed. This one is not. We have a problem. The build was successful. Well, now we just need to actually sign the application. In order to do that, you're going to have to create a couple things you probably don't have yet. You're going to actually create your own Java key store. You're going to basically set some things up as if you were an Android developer yourself. And to be honest with you, what you're doing is probably not much different than what so-called quote-unquote Android developers do themselves. So let's pretend we're Android developers for the video, and let's go. First, we need to create a signing key. To do that, we're using a tool called APKTool, pre-installed on Kali Linux. If I do a what is on APKTool, this is used as a key and certificate management utility. So we're going to run a very long command. I made this easy for you because, as I have been doing with pretty much all of my videos lately, I've been building documentation to go along with the videos. You can check out the GitHub, link is in the description, and you can copy and paste these commands. Essentially, you can copy and paste these commands and just change any minor things that you want to change. So we're going to run APKTool with -gen key. This is a generated key. We're going to do -v for verbosity, followed by -key store, because we are creating a key store, and this is where you can use any name that you want. I'm choosing to call this fresh-release-key.jks. You can call this whatever you want. Then we're going to do -key alg for key algorithm. This is going to be a RSA key. We're going to do a -key size, and we're going to create a size that is 248. Next, we're going to do -validity. This has to do with the length of the key. We're going to do 10,000, which I believe that means 10,000 days, followed by -alias. So you have to create an alias. I'm going to call my alias fresh-key-alias. Once again, when it comes to the alias and when it comes to the actual name of the key store, you can call those whatever you want to call them on your system. You're going to hit enter, and you have to create a key store password. Re-enter the password, and then you have to provide some details. You don't actually have to provide real details for this. Just make sure that you type yes at the very end, otherwise it'll make you cycle through everything again. So I'm just going to type fresh forensics for everything. And finally, at the very end, type yes to say that yes, this is all correct. We just generated a 2048-bit RSA key pair and a self-signed certificate with a validity of 10,000 days. And it has stored it under this name, in this directory. So if I run ls, you see that we now have that key store. We're going to need to use a tool called Zipalign. And the order of these tools is actually very important. So you can't mess the order up, otherwise this won't work properly. So the way that I am doing this, the next thing we need to do is use Zipalign. If I do, yet again, already pre-installed on Kali Linux. If I do a what is on Zipalign, this is used as an alignment tool for Android applications. But let's just take a look at the man page, because that's where we can get a better understanding of what this tool actually is, as well as how to use it. So I'm going to run man on Zipalign. So Zipalign is an archive alignment tool. It provides important optimization to Android application files. The purpose is to ensure that all uncompressed data starts with a particular alignment relative to the start of the file. And it goes on to say that there are one of two specific points in the app building process that you're going to use this. Which one depends on which app signing tool that you're going to use. We are going to use APK Signer. So that says that Zipalign must only be performed before the APK file has been signed. So we're going to run Zipalign with a -v for verbosity followed by 4. You're going to run it on your Modified APK. You can see where this quickly becomes very confusing because you end up with so many different versions of the same APK. So we're running on this on our Modified APK. And now we need to designate a new name for the new APK. So this one is going to be called Zipalign.apk. So you get a bunch of output on the screen. Everything pretty much, it just tells you everything that's being done, and you get an OK after everything. So there's quite a bit of output on the screen, but everything was done successfully. So now I'm going to clear the screen and run ls, and now we have yet another APK. So here is our original APK extracted from the device. This is the extracted file system. This is after we modified it, adding debuggable equals true to the android.manifest file. And finally, this is our new Zipalign version. So the next step in this process is going to be to sign the APK. To sign it, we're going to be using a tool called APK Signer. Once again, pre-installed on Kali Linux. I do a what is on that. This is used to sign and verify Android APKs. You can open up the man page for this. If you're wondering how I figure all this stuff out, I read the man pages. It tells you everything you need to know. I don't go out to the internet. Everything you need is right here in the man pages. That is how I get an understanding, a thorough understanding of a tool and how I can use it. Oftentimes you will find things in the man pages that you will never see other people talk about, because most people, they go out to Google instead of looking at the man page. So for each signer, you need to provide the signer's private key and the certificate. We just created that using APKTool. So we're going to run APK Signer followed by sign. I'm going to do --ks for key store, and then you have to specify that key store that you created. If I split the screen, if you forget the name of the key store, it's in the same directory we're working in. My key store is called fresh release keys.jks. So you're going to provide the name of the key store, followed by --ks-key-alias. This is your key store key alias. Also, you had free reign to name that whatever you wanted. Mine is called fresh-key-alias. And finally, you need to provide the name of the Zipalign APK. This is a lot, and it can get very confusing. So there are amazing scripts now that you can go get that will automate pretty much this whole process for you until something breaks and then you have no idea how to fix it. So we're going to hit enter. You have to provide your key store password that you previously created. And there we go. So now if I do an ls, this Zipalign.apk has now been signed. It is now officially signed. And we can verify that by running APK Signer with verify followed by the name of the APK. And if you get nothing back, that's a good thing. That means that we have successfully verified the signature. All right, so this is the moment of truth. That was the last step in this process. We can now attempt to install this modified APK back onto the device and see if we are successful. Now, just as a final step, this is completely unnecessary and I don't want to confuse anybody, but I am going to copy that APK and I'm going to give it a name that just lets me know that this is that end result, the fully modified APK. And I'm just going to call it com.fresh.debuggable. This lets me know that this is in fact the end product where I have modified the debuggable flag in the manifest. That just helps me because we have so many APKs now. And I'm going to end with .apk. It has to end with .apk or it will not recognize it. All right, so now I'm going to run adb install followed by the name of that APK. And as you can see, it was successful. This is our newly modified Android application. The install was successful. We have a debuggable version of an APK. This is incredibly powerful. This is very powerful what we now have. I'm going to run an adb shell, dump sys, and we're going to grep for debug. And this time, you see that we get back some different results. So this application is in fact debuggable. You might be asking yourself, what's the big deal? Well, it's actually a very big deal. It's actually a very big deal. I showed you a very powerful command. That is the run as command. But you can only use that command if the app is debuggable. So we're going to shell into the phone. We're going to get the name of that APK once again. We're going to get the name of that application by running pm list packages, piping that into grep. We're grepping for something with vaults. Notice that no matter what name we gave this, at the end it was called something debuggable. But when you install it back on the phone recognizes it as its real name no matter what you call it. Why is that? Because it's pulling the information from the manifest. That's where it's getting the name of the application from. So now that we have the name of the package, we're going to use the run as command. We're going to do run-as and then provide it with the name of the package. And grand finale, ladies and gentlemen, we now have access to the private data directory of this Android application. Which is interesting because I think it was just yesterday that I was asking ChatGPT, is it possible to access the private directory of an app? And of course it said no, it's not possible. Just as it says a lot of things are not possible with Android, it's also not possible to enable USB debugging with AT commands, but I've done that too. And come to find out, ChatGPT lies about as much as my ex-girlfriend, which is a lot.
A lot.
So we have just accessed the private data directory of the app. That is a big deal. Very, very big deal. We essentially are running as the user ID of this app now. So if I run the ID command, the user ID has changed. It's now 10302. So you have a full understanding of this. I'm going to run exit. Okay, and now I just exited back to my original user. If I run the ID command, we have a UID of 2000 shell. This is the regular user you shell into as the phone. There's no root user. So once again, if I perform the run as command and then run ID, we have changed users on this device. So we are now inside of where private data is stored in this app. If I do an ls, we have two directories. If I do ls-la to try to show hidden directories, there's no hidden directories. Okay, so what else do we have here? So let's see what's inside of cache. Apparently there's nothing inside of it yet. Yeah, there's nothing. So let's see if there's anything inside of code_cache. and there's nothing there. So there's actually no information here. Okay, well, let's create some information. So back on the phone, we're going to open up the app. And before I do that, I'm going to run the ls command one more time. So that's what it looks like. Back on the phone, we're going to open the app up. As I said, this is meant to be a note-taking app. This is where somebody might store, notes on their phone, like, hey, here's the password to my Wi-Fi network, or here's my shopping list, or whatever. Here's a phone number of somebody who, I don't want to store this phone number in my contacts because it shouldn't be in my phone, or, whatever. Might even be storing secrets in this secret note-taking app, whatever. Very simple. It actually sucks. It doesn't even work very well, but it serves a purpose. So let's enter a note. I'm going to enter a password. Password is password 123, and that password is the password to my Wi-Fi network. Okay, just some super basic note. In fact, this app is so crappy that when I come down here and click on save, you don't even know if it actually saved it. Like, it's still on the screen. So if I click save or load, like, it doesn't really even do anything, because I'm not an Android developer. I'm still learning how to create apps, so bear with me. It serves the purpose though. So now we have entered a secret into this app. Okay? So now if I come back over here and run ls, you now see that we have a new directory that's been created. It's called files. Gosh, I wonder if there's any files inside of this directory. Let's see. If I run ls on files, we got a file called secrets.txt. Let's cd inside of files. Let's make sure there's not any hidden files in here. Okay, so we have a file called secrets.txt. Let's cat out the contents of secrets.txt and see what we got in here. Oh my gosh, imagine that. Here is the Wi-Fi network and the password to the Wi-Fi network. That, ladies and gentlemen, is why you do not allow apps to be published to the public. You do not allow production apps to go out with debuggable equals true. In fact, nowadays, by default, if you build an app with the Android Studio IDE, you don't even need to add debuggable equals false in there. It just does it automatically for you. In fact, if you try to add it, it'll error out. It just automatically makes it false now. You don't even need to add the line anymore. But as you can see, by opening up the Android manifest file and adding this line to it, we were able to gain access to the private data of this app. So what's the takeaway from this? Same app, same device, but different trust level. That's the lesson. Security isn't magic. It's configuration. It's discipline. It's attention to small decisions that most people never even see. One flag, one oversight, one assumption, and the boundary shifts. But this isn't just about Android. This is where the real forensics begins. Because systems aren't the only thing built on trust boundaries. So are habits, so are beliefs, so is identity. We all run with flags enabled. Some of them quietly weaken the sandbox we think protects us. Most people assume their walls are solid. They never inspect the manifests. They never question the defaults. They never audit what's actually running beneath the surface. But if you want control, real control, you don't just trust the configuration. You verify it, you test it, and if necessary, you rebuild it. Because the power of a system isn't in what it promises, it's in what it enforces. And the same is true for you. This is Fresh Forensics, and the deepest investigations are the ones you run on yourself. As always, keep learning and stay fresh.
They said I couldn't do it, but I did it. They said I wouldn't make it, but I'm winning. I'm running Kali Linux, man. Who's with me? School at late night, coffee and glow. Thumbs on the keys where the secrets flow. Never fit the frame, never played it safe. Found a new language in a binary page. Mama prayed for me to find a steady 9 to 5. I told her I'll be steady, steady chasing.